we are going to learn about the thermodynamic concept of energy. Okay, so energy is classified into two forms. One is a static form, another one is dynamic form. So static form means it is the energy stored in the system. Okay, so it is the energy related to the molecular activity. Let's take an example of cup of coffee. So in this case, suppose the this coffee is having a some temperature post 70 degrees Celsius, right? So the molecules of the coffee will be having some energy. They may be translating, rotating, vibrating. So all this is energy. If I combine all this energy, whatever is the energy stored in the coffee, that is the static form of the energy, and that is also called as the internal energy. So it is the energy stored in the system. But when I consider the dynamic form of energy, in case of dynamic form, it is the energy which is there is energy interaction between the system and the surrounding. So it is the energy which is recognized at the boundary. Now suppose this is your system. Okay, so this is my system, and everything external to the system is my surrounding. Okay, now if the surrounding is at a temperature of suppose 25 degrees Celsius, so this coffee will definitely transfer some heat to the surrounding. So the heat transfer is taking place at the boundary. So it is a dynamic form of the energy. So I hope the difference between the static and dynamic form is clear. Okay, now we'll learn about the internal energy in detail. Okay, so now what is meant by an internal energy? Okay, so as we discussed just now, it is the energy stored in the system. Okay, so total energy contained or stored in the system, that is called as the internal energy of that system. It is sum of all the microscopic forms of energy. Let's understand what is meant by this microscopic forms of the energy. Okay, so in microscopic form, if I take the same example, in microscopic form, the molecules, okay, so these molecules, here I am taking an example of liquid. It can be solid, it can be gas. Okay, so if the molecules are moving, okay, so they will have some translational energy, translational kinetic energy. Okay, now translation will be there. Maybe the molecules will be rotating. Okay, so some rotation will be there, plus vibration and all other form of energy which are stored in the system is the internal energy of that system. Okay, so whatever kinetic energies associated with the translational, rotational, vibration, or maybe spin. Okay, so that is the, if I take sum of all, that is the internal energy, and it is also called as the microscopic form of energy. All these translation, rotation, when we are dealing with the molecular level, it is the microscopic form of the energy. So I hope the difference is clear between static and dynamic form. So let's take an example of um, here I've taken a some mixture you can consider. Okay, maybe any kind of liquid, and I'm using a hand blender. Okay, and with the hand blender, suppose this whatever liquid is there, whatever mixture is there, it is having the same temperature as the surrounding. Okay, this is also at 25 degrees Celsius, this is also at 25 degrees Celsius. So when you use a hand blender, means you are supplying some kind of work. Okay, so when you use the hand blender, the molecules of this liquid will start moving fast. Okay, so you are transferring some energy in the form of work, and that energy is actually increasing the internal energy of the system. Okay, so when the molecules will be moving faster, the temperature may rise. So whenever the temperature increases, the internal energy also increases. Okay, so most of the book, internal energy is represented by capital U. So when temperature increases, internal energy also increases. So I think the concept of internal energy is clear. Thanks for watching. If you have any doubt, you can write in the comment section.